we are going to look at one of the most important numerical methods called as the Newton-Raphson method. The way we are going to look at that is by first looking at an example, and then we'll look at the theory behind Newton-Raphson. Problem that we are going to look at is the following recursion relation, when started from a finite positive non-zero value, converges to dash, where the recursion relation is xn plus 1 is half of xn plus 1 by xn. So let's first understand the question, then let's solve the question, and then let's go to the theory. Okay, it's a recursion relation. What it means by that is, given old value of x, say xn, okay, we get the new value of xn by this relation. For example, if xn is 0.5, 1 over xn is 0.5 by 1 by 0.5, which is 2. Half of that is half of 2.5, which is 1.25. This is a new value of xn. Then we use this as a old value and keep on finding subsequent new values of xn. That's a recursion relation. And what we want is, we want that value of xn plus 1 when things are converged. Okay, so when things converge, it's like Groundhog Day. You wake up, you do so many things, then you go back to sleep. The next day, start over again, right? You are on the same place, same time, doing the same thing. Like that, we start out with some value, but after doing this iteration for some number of times, okay, when we do this iteration, we end up with the value that we started with. This is known as convergence, okay? So we want the value when things have converged. So just solve for this particular equation for xn, okay? So let's do that. So xn is half of, this is xn square plus 1 by xn. Let's take the 2 and xn's to this side, 2xn square, okay? So this means xn square is 1, xn is 1, no, it's plus or minus 1. This is important because what we are given is, it starts with a finite positive non-zero value. First it's non-zero. What happens if the value we start with is 0? It's 0 plus 1 by 0. Things blow up, right? So it's non-zero. We start out with something non-zero. That's good. Then we start out with a positive value. When we start with a positive value, xn is positive, 1 by xn is positive, 1 over xn is positive. Agree? So the sum of the two positive values remain positive. The new xn plus 1 will be positive. We keep on doing this, all subsequent values of xn plus 1 will be positive. So the moment we start out with a positive non-zero value, the only term that we get here is not plus or minus 1, it's plus 1. Had this thing been finite negative non-zero value, we would have ended up with a value of minus 1. Fine. So the answer here is 1 plus 1, okay? And we are done with the example problem with that. At this point, curious students might ask, how did someone ever come up with this particular relation? Why did someone come up with that? Where are these things useful? We started this video saying this is one of the most useful numerical methods, right? So let's look at that. So let's say we want to find a root of a given number, say 97. How do we do that in a computer? Such problems are solved in computers by iterative means. We keep on doing some procedure again and again, simple operations. Here it's division and addition, perhaps division, right? Simple operations to find complicated functions like roots, exponentials and things like that. So what we want is, we want to find, say, x square as some value, say 97, or in a computer, let's say some general number n. Right? We want to find the value of x for which n is the squared value. Fine. How do we do that in a computer? First, we write this as an equation. We want a solution of an equation such that, say, f of x, okay, is xn square minus 1, and we want f of x to be 0, because when x is a square root of n, this term becomes 0. How do we solve for f of x? Okay, we use the Taylor's approximation. That is, a given function f of x n plus 1, say the new value is approximately equal to f of x n plus the slope of that function at x n times delta x. I stop with, there are many more terms in the Taylor series, I stop with the first order terms. Agree till this point? This is just Taylor series. From here, let's say we start out with xn. The new value of xn plus 1 we are trying to find. We are trying to find such a value that it satisfies this equation. Okay? When it satisfies this equation, we want ideally the xn plus 1 to be 0. Agree? But it's only approximately correct. First order approximation. So we want to keep on doing this a few number of times until we find the actual solution. We keep on iterating like this until we find the actual solution, until things converge. Hopefully they do converge. What is x? Delta x over here. Delta x is x n plus 1 minus x n. Okay. So from this, let's write for what is the new value of xn. So on this side we have 0. That's a condition that we are trying to solve for. So xn plus 1, just solve for this. This will be minus f of x by f dash of x plus xn. Okay. So given any function f of x, when we are trying to find f of x is 0, do this iteration. It will converge under many conditions and it will converge pretty fast. Okay, that's why it's very important, it's very useful. Okay, at this stage, let's say we want to find the roots for x square minus n. What is f of x? F of x is x square minus n. Agree? What is f dash of x? Derivative of this is 2x. Okay, so 2x, and of course we are looking at the nth value. Fine. Let's simplify this expression, whatever we have here. Okay, what we have here is, let me bring this minus over here so that things are clear. Okay, so let's simplify this. This becomes 2xn square. Okay, 2xn square by 2xn. Okay, that becomes this term and this term cancels. Okay, and what we are left with is xn square plus n by 2xn. And let's write it in a slightly convenient form. Okay, so let's bring the half out of this, which is half. Okay, took the 2 outside of it. Let's write this as xn square by n, which is xn. Okay, and then n by xn. Just write the 2, split the numerators and divide them separately. Okay, if n is 1, okay, if n were 1, we will end up with the relation that we are given. So essentially, we will take the general recursion relationship for finding the roots of a given number n, substitute n and form the quotient. That's what was given in fact, one of the GATE exams. And this is the reason these relations are useful, and there's a short theory behind it. Of course, one could go further and ask, is this thing ever going to converge? How fast does this thing converge? Right? We want to compare things against other methods and all that, and we also want to quantify how fast things are going to converge, guarantee convergence and all that, which raises a question for you all. Okay, what we did here is what is known as a Newton-Raphson method using the Taylor series approximation. By making a small change here, we can also get the secant method. Okay, so can you instead of Newton-Raphson, can you do the secant method for finding the roots and see what the recursion relationship is in the comment section. Let's see who comes up with the right answer. I'll see you with another video, and good luck.